In today's video, I'm going to talk about voting, which I think will be of interest to at least some of you who major in history and government, but also I think it's an interesting topic on its own, and it utilizes some of the same tools that we use to talk about consumer behavior, so it won't be completely unfamiliar to you. You would just see how the same basic um, framework of complete and transitive preferences over outcomes is used in a slightly different setting. So, okay, voting. This video is based on sections 1 through 4 of chapter 23 in networks, browsers, and markets. I think if you go on the syllabus, there is a link to the PDF of the text, so you should be able to get that text, that chapter for free online, and I will try to post it on Moodle as well. And so today I'm going to focus on just two things. I'm going to talk about two kinds of voting systems, majority voting and positional voting, and you will see that you're actually familiar with those voting systems already. So I'm just going to talk about what kind of rules these are and what kind of problems arise when these rules are used. But before we talk about voting systems, we need to motivate it by basically talking about what voting is from the decision-making perspective and how we model it. So here's the idea. Think about a voting situation as any situation where a group has to make a decision. And I'm just going to follow the language of the textbook, and that decision has to speak for the group. That is, you need to settle on one particular alternative, even if you personally don't like that alternative best. In examples of voting decisions could be determining the next president in presidential elections or any other kind of elections in general, or determining which movie will get an Oscar. So when members of the Academy meet and decide which nominee will actually win the nomination, they also have to use some kind of procedure in which they will, as a group, determine who is the winner. Or if the jury needs to vote on whether finding the defendant guilty or not guilty. There's also a particular voting rule involved in that kind of situation. So basically, we're going to be looking at decision making in groups. And so here's the framework for this problem. We're going to have a finite set of alternatives, and here I'm just using capital letters for alternatives. And then there's also going to be a finite set of agents or group members, and for them I'm just going to be using numbers. I'm going to index them. An agent with a number I would have complete and transitive preferences over the set of alternatives, and to make things a little bit more simple, there's not going to be any ties. So that means that the agent can always say whether he or she prefers A to B or B to A without the possibility of tying between A and B. So the agent always leans toward one of the two alternatives. And then transitivity means that there wouldn't be any cycles of preferences. If A is better than B from the agent's perspective and B is better than C from the agent's perspective, then A has to be better than C. And this definition of transitivity should be familiar to you by now, and focus on it because I'll be using it today more than I used it when talking about consumer choices. So the goal is, given the preferences of agents in the group, we need to come up with a group preference relationship. We need to rank alternatives from the group perspective as a whole, and again using the textbook language to make it in such a way that it would reflect the collective opinion of the group. It's not exactly clear what that collective opinion should be, but the idea is, you, as the input, you take a collection of individual preferences, and then given some voting system, the output will generate a group ranking. And of course, if you focus on particular examples, well, with the presidential elections, we don't get a complete group ranking, but rather we try to find out the best alternative, the alternative that's somehow most preferred by most members of the group being the US citizens of voting who can vote. But in general, the question of selecting the best or selecting a complete group ranking is the same question, because if you can select the best, then you can use the same procedure to select the second best, the third best, and so on. And so ultimately, you'll end up with a group ranking. And so I'm going to focus on the group ranking because it's going to be a more general setup. But the idea easily reduces to more simple cases when you just need to select the best. And so here's the first example of a voting system. This voting system is called majority rule, and majority rule is a system that's based on the following principle. If more than half of the group members prefer alternative X over alternative Y, then the group as a whole should also prefer that alternative to Y. So X should be preferred to Y if more than half of the group members prefer it. And if there are only two alternatives, that's trivial. If you need to select as a group between two alternatives, just have a vote, and whichever alternative gets the majority of the votes wins. That's how it works with just two alternatives. But if we increase the number of alternatives, any number above two, things might get tricky. Sometimes with many alternatives, you can still vote and still get a single alternative that gets more than 50% of the vote, and that should be fine. But in other situations, and I'm going to talk about it right now, aggregating preferences using the majority rule will create problems. And so here's the idea. That's the simplest example that illustrates this idea. Suppose you have three individuals, person 1, person 2, and person 3, and three alternatives A, B, and C. And person 1 prefers A to B to C, person 2 likes B better than C better than A, and person 3 likes C better than A better than B. Now, how should group preferences for this group of three agents look like? Well, following the majority rule, we need to take each pair of outcomes and compare them based on who the majority of agents would prefer. So let's start with A and B. From the perspective of agent 1, A is better than B. From the perspective of agent 2, B is better than A. From the perspective of agent 3, A is better than B. So 2 out of the 3 agents prefer A to B, and so clearly with 3 agents, 2 form a majority, and so if the majority prefers A to B, so the group preferences have to reflect that. So under majority rule, A has to be preferred to B because of agents 1 and 3. What about B and C? Agent 1, B is better than C. For agent 2, B is better than C. So agent 1 and 2 form a majority, so B should be preferred to C. But the problem is that if we look at C and A, agent 2 and agent 3 prefer C to A. So the majority rule tells that the group should also prefer C to A. And so here we run into a problem which says that the group preferences should be the following. A is better than B, B is better than C, but C is better than A, which is problematic because it violates the important property of transitivity. Agent 1's preferences are transitive, agent 2 preferences are transitive, agent 3 preferences are transitive as well, but when we aggregate them using the majority rule, we lose transitivity. And this is problematic. We can't figure out the winner if transitivity is lost sometimes. So the major problem with the majority rule is that with more than 2 alternatives, group preferences based on the majority rule need not be transitive. Sometimes they're transitive, and if they're transitive, then we can pick the best option. But if they're not, picking the best option is problematic. How can we get out of this transitivity problem? One suggestion is to basically do pairwise comparisons, compare 2 alternatives, throw out the loser, keep the winner, and compare the winner to some other alternative, and continue until only one alternative is left. You can think of it as pairwise elimination. And so, for example, going back to the story with 3 agents and 3 alternatives, let's have the agents first vote between A and B, and then we'll take the winner of A and B and compare that winner to C and see who wins. Let's go back to the table. If we were to compare A and B, we know that A is preferred to B because 2 of 3 agents would vote for A over B. So the winner of A and B versus B is going to be A. But if we were to vote between A and C, the group would prefer C because 2 of 3 agents prefer C to A. So in this procedure where we first determine whether A or B is better, and then looking at the winner versus C, C is the best. And the problem with this pairwise elimination is that if we were to change the order in which we vote between pairs of alternatives, for example, if we were to vote between B and C first and then compare A to the winner of B and C, the overall winner of this procedure will be different. And so this problem is called the strategic agenda setting, where if you were to vote over alternatives on the agenda in a pairwise fashion, it's really not about voting anymore, but more about how you place those pairs, in what order you place those pairs on the agenda. And so this kind of problem really comes up when parliaments have to vote for certain decisions because they oftentimes do it in a pairwise fashion. Okay, that's it about the majority rule. And the next thing we're going to do is we're going to talk about positional voting. Positional voting is a different way of determining the winner. In a positional voting system, every individual comes up with a ranking of their alternatives, and based on the ranking, each alternative gets points from each individual. And then we add up those points for each alternative and create the group ranking based on the sum of the points that we assign. And the simplest example of positional voting is called plurality voting. Plurality voting simply says for each voter, for each agent, each group member, the top choice, their top alternative, gets 1 point, and all other alternatives get nothing. And you can encounter plurality voting in presidential election. And I'm going to focus on one particular example. In presidential election, usually there are more than 2 candidates, so majority voting with 2 candidates is sometimes not applicable. So there are more than 2 candidates, and when you go and vote for the president, you pick your most preferred candidate, and that candidate gets your vote, and in the end, all votes are counted, and whoever gets the most votes, even if it's below 50%, gets the nomination from a particular state. So here's the example from 2000 from the presidential election in Florida. There were several candidates, more than 3. I'm only listing the first 3 choices: George Bush, Al Gore, and Ralph Nader. And you can see that Bush won the election in Florida with a margin of less than 1,000 votes and less than 0.1% of all the votes. So 48.85% voted for Bush, 48.84% voted for Gore, and 1.6% voted for the third candidate, Ralph Nader. And in the end, Bush won. And so the problem with this kind of voting, plurality voting, is that we don't know if people who voted for Nader actually would prefer Bush over Gore. This kind of voting system does not reflect their preferences. And had they known that Bush is going to win over Gore, would they really have voted for Nader, or rather, should they have voted for Nader in that case? That system does not give the answer. And so the problem that the system creates is the problem of strategic rather than sincere voting. Clearly, people who voted for Nader were sincere voters in the sense that they picked their first best choice on the ballot, presumably knowing that Nader is not going to win the nomination from Florida. Strategic voting would then mean, okay, I'm a big Nader fan, but I know that he's not going to win, so who should I vote for, Bush or Gore? What would be the second best for me? And so the interesting question is, how many of the Gore voters and how many of the Bush voters were actually had Nader as their first choice, but decided to vote for somebody else instead, knowing that their first choice is not going to win. So, to sum things up, with plurality voting, the real problem is that you have to strategize, and there is no clear way of doing so, and thus the outcome could be far from reflecting the real preferences of the voters. Although I'm not stating that it was indeed the case in this situation. I'm just saying that we don't know what Nader's voters would have done with their second choice. A more elaborate example of positional voting is called border count. And so in the border count case, with n alternatives, we're going to distribute points the following way. The first alternative will get n minus 1 points, the second alternative will get n minus 2 points, and so on. The second to last alternative will get 1 point, and the last alternative will get nothing. And the example of how border count works is as follows. Suppose that we ask 5 critics to select the greatest movie of all times, and that is an example from the textbook, so I'm not responsible for the selection of movies. And suppose that critics 1 to 3 generally agree that the best movie of all times is Citizen Kane, the second best is The Godfather, and the third best is Pulp Fiction. And critics 4 and 5 think that, well, strictly speaking, Godfather is better, Pulp Fiction is the second, and Citizen Kane is the third. How should they come up with a group decision using the border count? Well, for every first pick, a movie should get 2 points from a critic because we have a total of 3 alternatives, so n minus 1 is going to be 2. So every time Citizen Kane goes first, that movie gets 2 points. And Godfather gets 1 point, and Pulp Fiction goes with 0. So every first alternative gets 2, the second alternative gets 1, the third alternative gets 0. So now let's calculate how many points each movie gets. Citizen Kane gets 2 points from 3 critics, that's 6 points, and then 0 points from critics 4 and 5 for a total of 6. So using border count, Citizen Kane in the end gets 6 points. Godfather would get 3 points, that is 1 point each from critics 1 to 3, and then 4 more points from critics 4 and 5 for a total of 7. So 3 second places and 2 first places give you 7 points. Pulp Fiction gets 0 from critics 1 to 3 and 1 point each from critics 4 and 5 for a total of 2. So here is our final ranking using border count. Godfather wins with 7 points, Citizen Kane finishes second with 6, and Pulp Fiction ends up last with just 2. And that's an okay way to decide who the winner is. And for example, the best soccer player of the year is decided just like that by asking players and coaches to vote on their best 3 or something. You can check it out. But the problem with this kind of voting system is that it does not agree if you used the outcome of this decision-making process does not agree with the outcome of, say, majority voting. Because if we did majority voting, well, Citizen Kane would beat Godfather 3 to 2. So Citizen Kane would be majority choice between it and The Godfather, because 3 critics would vote for it and 2 critics would vote for The Godfather. And it would also beat Pulp Fiction 3 to 2. So Citizen Kane should be the majority voting selection, but it loses using the board account selection process. So I'm just throwing this last example here to show that depending on the voting system with the same set of original preferences, the outcome, the ultimate group ranking would be different. And so that clearly is problematic in its own way as well. And that is all I have for today. Thank you very much for your attention.